KarunaweeraNadira is going to talk about genetic correlates of declining transmission Plasmodium vivax in Sri Lanka.
Thank you. Thank you. Before I start, I would like to mention others who were involved in this project. Shamini Gunawardena and GMG Kapilananda from my laboratory at the University of Colombo, Sri Lanka. Marcelo Ferreira from University of Sao Paulo, Brazil, and Diane Worth from School of Public Health, Harvard University. Sri Lanka, as some of you may know, it's a relatively small country. I don't have a map here to show. It is an island which is located just to the south of India. The country has plans to eliminate malaria by year 2014. And I must add that we are on track and we haven't seen a single indigenous case or locally acquired case of malaria since October 2012. This is to show you the number of malaria cases reported from the country over the years from 1995 onwards. As you can see, there was a drastic reduction in case numbers since year 2000 or so. And for the purpose of this talk, I will be focusing on this period from 2003 to 2007, where the case numbers reduced from about 15,000 to couple of hundreds. This figure here shows the number of cases reported during the past few years since 2008 onwards, and the two colors representing the locally acquired cases in brown and yellow showing the imported cases. As you can see, there's a gradual reduction in locally acquired cases, the dwindling numbers and total disappearance in 2013 onwards, while the travelers' malaria continues. So in this backdrop of malaria elimination, the surveillance has been strengthened with early case reporting, case investigation, and careful management of cases according to guidelines set by the World Health Organization. The objective of this study was to examine whether the recent dramatic decline in malaria transmission in Sri Lanka, whether it led to a major bottleneck, as one would expect, in the local parasite populations with a substantial decrease in the effective population size. And we have focused on Plasmodium vivax because it is the predominant species. It has been responsible for over 80% of all malaria infections reported during the past so many decades. So for this study, we used 185 Plasmodium vivax patient isolates spread across the country from endemic areas from 13 districts as shown here by these dots. And genotyping was done using a set of microsatellite markers that we have previously described, 14 to be exact. And this figure, this table shows a summary of these markers, the name of the locus and the loci and the chromosomal location with the core repeat sequence with respect to the reference strain of Plasmodium vivax, which is the cell1 strain. You can ignore the rest, which I will come back to during results. So we use the single or predominant allele at each locus for computing allele frequencies, and the presence of additional alleles with a peak of at least 1/3 of the height of the predominant allele at a locus was considered as a second allele, and it was labeled as a mixed clonal infection or multiclonal infection. Genetic diversity of the parasite population was determined by using standard techniques by calculating the expected heterozygosity or HE, and genetic differentiation between parasite populations both spatially and temporally was assessed by using FST or pairwise fixation index. Effective population size was estimated using methods described by Anderson et al. In detail in 2000. And the estimates were based both on the infinite allele model and the stepwise mutation model. We also looked for evidence of bottleneck signatures, as one would expect in a scenario like this. And there were 3 methods that were used to verify if population had indeed suffered a reduction in size with a bottleneck effect, as it's popularly known. And these are the methods used to look at these signatures. And the results indicated that it confirmed that there was high degree of polymorphism and diversity, as we have seen previously in these parasite populations in Sri Lanka, with nearly all except a pair of 184 unique haplotypes. So except one pair, all the others were unique haplotypes. Number of alleles per locus ranged between 12 to 46, while the genetic diversity remained high at levels of 0.87. When we looked at it over time, allelic diversity, there was a slight decline, including heterozygosity values. So there was a decline seen, although the values remain high. Almost 70% of isolates were mixed clonal infections. And when we looked at over time, these mixed clonal infections numbers and the percentages did not have a decline in trend over the years. Then we looked at spatial and temporal differentiation of parasite populations. This table shows the genetic differentiation that we looked at provincial level, depending on the origin of the parasite isolates. These are the different provinces given on these sides, and the clear boxes indicate the significant values. So there was parasite genetic differentiation between populations originated from different provinces. And this was true even at district level. When we analyzed at district level, these are the different districts, and the significant values are given in clear boxes again. So there was significant parasite differentiation even at district level. Then we looked at the temporal association, that is over time, and again there was significant differentiation of these parasite populations in different years. Effective population size, although it remained relatively high, it did show a decline over the years from 2003 to 2007. These are the 2 methods used. And then we looked at the genetic bottleneck effect with these different methods, and this was demonstrated only with the M ratio test. So it was possible to demonstrate a genetic bottleneck effect using the M ratio test only. The other 2 didn't give such an evidence. So what do all these things say? It does indicate that there is persistence of high genetic diversity and multiclonal infections with only a marginal change or reduction in population size, despite the drastic decline in incidence of Plasmodium vivax in Sri Lanka. And in a practical sense, this probably highlights the importance of maintaining stringent control and surveillance measures to prevent a resurgence. From a scientific point of view, it does indicate that there should be, or we should be looking for more precise or more accurate tools in order to show evidence of genetic signatures of shrinking malaria transmission, as is seen, as should be seen in places like Sri Lanka. And before I end, I would like to acknowledge financial support from National Research Council Sri Lanka and NIH USA. And also I would like to thank the director and the staff of National Malaria Control Program, Ministry of Health, Sri Lanka, that enabled this study. Thank you.
Hi, thank you for an excellent talk. I'd like to offer an alternative explanation and a positive one for your high effective population size, and that is that if every single parasite is being imported from somewhere else, you're going to see a lot of diversity. And so if you've completely eliminated malaria from Sri Lanka, then you're going to see a high effective population size, just like you'd see if you looked at all the parasites that we had here in the United States.
Right. Thank you.
What also might be the role of the hypnozoites? Can you track these back to know what year that actually reemerged? Is that part of this?
No, we haven't been able to do that, no. Yeah, it would be interesting to see what proportion would be responsible.
Because are they mostly in adults, or is this that the adult became parasitemic, a mosquito bit them and gave it to a child?
There were like all ages were affected, but the numbers are very little.
It really confuses.
Exactly, yes. We are trying to look at serology in a sense to answer some of these questions.
Any more questions? Or we will move on to the next talk. Thanks.